Hi, this is Kevin Trainer. Welcome to my lecture on Chapter 7 of the third edition of the Murach MySQL book. Chapter 7 is called How to Code Subqueries. This is part 1 of 2. I've divided the chapter to separate the content that's been in MySQL and in the Murach series of textbooks for quite a while. So part 1 is the long-term stuff, and part 2 we're separating from part 2, which is the new stuff. So it's new to MySQL. It was added in version 8, which is pretty recent, and it's new to the third edition of the Murach MySQL text. So here we go on the part 1 stuff. How to code subqueries. So we come to the objectives, and as usual, I'm going to leave those for you to read. There are 4 ways to introduce a subquery, okay, within a select statement. We've actually seen in prior chapters, we've seen subqueries used in a create table statement, and we've seen them in a couple of places. Within a select, they can appear in the where clause, in the having clause, and not too surprising because the having and the where are comparable. The where having to do with the filtering out of rows from the unsummarized result set, and the having to do with the filtering out of summary rows from the summarized result set, right? So in the where, in the having, in the from, and in the select clause itself as a column specification. All right. Now, I'm going to give you a kind of a point of view that I've found helpful in thinking about subqueries over the years. So I'm going to share that here, and that is in a particular spot within a query, within the syntax of the statement that you're trying to do. If you're inserting a subquery, what are you expecting to bring back? Okay. And typically, let's think about queries in general, selects. What can they bring back? Well, they can bring back a full table, rows and columns. Okay. That's what we typically expect, right? They could bring back a single row. If we have a summary query and we don't have a group by, we're typically expecting to get a single row, okay? So those are the varieties that we get in the multi-column result sets. In the single column result sets, we're either bringing back a single value, one column, one row, or we're bringing back a list, so one column, multiple rows, okay? So usually what we're expecting to use as a subquery, we're usually expecting to bring back either a single value or a list or a whole table. I can't think of a situation where we're expecting to bring back a table and we know it only has a single row. Well, I guess there could be. It's just a subset where we're expecting a table. Okay, so if you always ask yourself when you're reading the select and you come upon a subquery, ask yourself, well, what are we bringing back? Okay, what does the statement need now? Does it need a single value? Does it need a list of values? Does it need a whole table? Okay. And in various scenarios, it's going to need one or the other of those things. And realizing that, I think, helps you read the query and understand it a lot. Likewise, when you're going to write the query yourself and you realize you're going to have a subquery that you're going to write, it really helps you sort of understand your motivation. It's like, okay, I need a query that brings back a single value. I need a query that brings back a list of values, one column, multiple rows. I need a query that brings back a whole table. Okay, so I'll try to emphasize that theme as we go through the chapter because I think it helps. It helps me. I'm hoping it helps you. Okay, so right off here on slide 4, we have a subquery in the where clause. Okay, and you're going to see a lot of these. Okay, and let's see, we're selecting 3 columns from invoices where invoice total is greater than, and then we have a query that calculates the average of the invoice total from invoices. Okay, so that's, what's that going to bring back? Well, we're asking for the average of a single column. That's going to bring back one row, one column. That's going to bring back a single value. Okay, so that's going to be invoice total greater than the single value that comes out of that query. Okay, and let's just look. The value returned by the subquery turned out to be 1879.74 blah blah blah. How did they find that out? Well, they just took the subquery, copy pasted it, and ran the query by itself, and this is the answer that they got. Okay. Then the result set, you see you've got 21 rows and you've got 3 columns. Now, I think you also ought to be asking yourself, well, why do I need a subquery here? And here's the use case, okay? What we're looking for is we're looking for invoices that are big, okay? And again, we're doing accounts payable. So these are obligations of our company. These are things that we bought and deadbeats that we are, we haven't paid for them yet, right? So we're going to want to see the big ones. It's always, when you're running a business, it's always hard to come up with the cash to pay the bills. You could have a very healthy business, growing in a very healthy way, but you could be short cash, okay? Businesses need a lot of cash to run. And so you always have your eye on, well, what do I have to pay this a month? Okay. It's not real different from paying the bills in a family or for a single individual. Okay. So the idea that you'd want a value in the where clause that helps you figure out the big ones makes a lot of sense. So why not just hard code a value? Okay. Well, you could. For instance, you could run the subquery one time as a query all by itself, and you could go, well, the average is around 1879. So let's say greater than maybe 1880, right? We do something like that. Well, the problem is that things shift over time. You might have times of the year where invoices are higher than others, times of the year when they're lower. Of course, with inflation, they're going to change from year to year. A query like this one that has a subquery that uses average, you're going to be able to write this once and forget about it. Okay, so I think it creates a lot more value than the lesser version, which have just one single hard-coded value. Okay, so that's why we're doing it, and that's how it works. Now, here's a query that uses an inner join. We offer this as an alternative. Okay. Or is it? Oh, I'm sorry. No. The first one, all by itself. Okay. The next two slides, these are going to show things. One, you do it with an inner join. The next one, we do the same work with a subquery, and then we kind of compare their pros and cons. Okay. Okay, so what are we looking for? We're selecting invoice number, date, and total from invoices, join vendors. We're joining on vendor ID, where vendor state is equal to California. Order by invoice date. Okay, so we get 40 rows. It's order by invoice date. We have the invoice date and the invoice total. Okay, that's the total for that invoice. Okay, now let's go look at the subquery equivalent. So select invoice number, date, and total from invoices where vendor ID is in. Select vendor ID from vendors where vendor state equal California, order by invoice date. So we get 40 rows. Okay, we get the same values. All right. Now, the question might come up. Is one of these more efficient than the other? And I'm going to say that they're probably close enough. I mean, I haven't personally measured them, but I'm going to say that they're close enough that you shouldn't worry about that. Okay. What you should worry about is what reads better for you and your coworkers. Okay. Because I think that the performance of these two is going to be in the same kind of general neighborhood. Okay. For me, okay, I like the one with the subquery. I think that reads particularly well. You kind of understand the problem, I think, better in version 2 with the subquery than in version 1 without it. Now, you could disagree. There's no correct answer to this. Okay? So what's kind of interesting here, let's go back to our first example. Our first example was not really solvable without a subquery. The alternative was to hard code a value, and that wouldn't be as robust and long-lived. Okay. Whereas the second and third are alternatives. We don't have to use this subquery. We could get away without one. So we're going to be asking ourselves what our preference is. Okay, and again, I think their performance is going to be in the same ballpark. One of the reasons their performance is going to be on the same ballpark is that SQL servers are allowed a lot of latitude to interpret your query, and they can figure themselves how similar these two queries are. So I think what you're the most interested in at this point is what's the best expression of your problem? Is it this inner join version on slide 5 or the subquery version on slide 6? Now, if you have this opportunity to choose between joins and subqueries, here are some thoughts here on slide 7 about how you might trade them off. So the advantages of joins: a join can include columns from both tables. We mean in the result set. Okay. Whereas you can include columns from a query that's in the where clause in a subquery in the result set. Okay, so that might really make the decision for you. And it says a join is more intuitive when it uses an existing relationship rather than some kind of ad hoc relationship that's not built into the database with foreign keys and foreign key constraints, which we're going to fully learn about when we get to chapter 10. The advantages of subqueries. A subquery can pass an aggregate value to the main query. That was what really made it so useful for us in the first example we looked at. Next, a subquery is more intuitive when it uses an ad hoc relationship. And last, long, complex queries can be easier to code using subqueries. And that's probably true. Okay. But the real question that you want to be asking yourself, first of all, you want to write a query that gets a correct answer. And second of all, you want to be asking yourself, which one is a better expression of the problem for me and my coworkers who are going to have to maintain this code over time? Now, in the where clause, we have a really good version of the where clause where we say where test expression either in or not in, and we have a list. Okay, so a subquery, you remember, it can bring back any kind of result set, but if it's a list, then probably what we want to bring back is a single column, multiple rows. That's a list. Okay. So this is a query that gets vendors without invoices. Select vendor ID, name, and state from vendors where vendor ID is not in. Okay. Select distinct vendor ID from invoices. Okay. So this gives us a list of all of the vendor IDs that have invoices. Okay, we don't have any duplicates, so we have a shorter list because we have the distinct. So that makes a proper list. Could you have a list that has duplicates in it? Yeah, I think I've tried it and I think it works, but it's not a good practice. So if in fact your query could generate duplicate or redundant values in the list, then you're going to pump in the distinct to get rid of the duplicates. That's a good practice. And then we order by vendor. So we're going to get a list of vendors that do not have any invoices currently in the invoices table. Okay, so the subquery that gets the distinct vendor IDs with invoices, there are 34 rows. That means I think we have 122 or 123 vendors. I think we have 122. Okay. So if in fact we ask for the vendors with invoices, we would get 34 rows. If we ask for the vendors without invoices, we would get kind of the opposite of that. We'd get the 88 that don't have any invoices. So that looks good. Now here's the query restated without a subquery. So we want to select vendor ID, vendor name, vendor state from vendors left join invoices on vendor ID where vendor ID is null. Okay, so this is a classic outer join. Okay, and as usual, if we organize the result set the way people, at least people in the US, like to read result sets, which is top to bottom, left to right, then you're going to use a left join. Okay. And so we're going to get all the vendors. Okay. And then we're going to get the what's going to happen is that if it doesn't have an invoice, then what's going to show up in the result set for the invoice ID? Well, it's going to be, or I'm sorry, for the vendor name and the vendor state, right? Well, I'm sorry, I'll back up. It says where vendor ID is null, so we're not showing the vendor ID. Okay. Um, but the vendor ID, the vendor name, the vendor state would all be null on the right part because there's no match because there's no invoices. Okay, so we're getting that, and we're only choosing to keep the rows where we got a no match. Okay, which is not usually the usual case, but and then we order by vendor ID. All right. So again, which would you prefer of these two? I don't know. I could see it either way. Okay. I could see it being, I think, query version 1 on slide 8, I think it reads better, whereas version 2 on slide 10 is really based upon a bit of a coding trick, which is when we use the left join and we have a row that fails on the right side, we know that the right side values are going to be equal to null. So again, I think you can take your pick based on what you and your coworkers think is good maintainable code. Okay. Okay. What if in the where clause we're going to use a comparison operator? Well, this is going to work the same way in most of the cases here. Okay. What we're going to do is we're going to have we're going to wind up with a list. Okay. And so it's going to work the way list values would work if they were hard coded, but they're not hard coded. They're being generated by a subquery. So let's look at the first one here. So we're selecting from invoices, invoice number, date, balance due. From invoices where balance due is greater than 0 and balance due is less than, and now we're going to have the average of the balance due. Okay, order by invoice total descending. So this is like the first example that we saw in the beginning of the chapter. There's really no great way to do this without subqueries. Okay, this allows you to calculate an aggregate value, which is always going to be, I mean, if it's the average, it's always going to be the average. And as the data in the database changes, this value is going to shift appropriately. The only alternative to this would be a hard-coded value. So in this case, we're expecting to get a single value back, not a list of values. And again, without subqueries, we would be left just hard coding some value that kind of makes sense. Okay, but over time it could really age. It could be too small or too large. Okay, so the subquery gives us more capability than we would otherwise have. So here's the value returned by the subquery, 2910 and high change almost 2911. Okay. So there are times when when we're going to get a list of values out of the subquery. Okay. And there are times when we're going to do a comparison and we're going to use greater than, less than, equal, or not equal to. And then we're going to have some expression, in this case, all, and then we're going to have a list. So the question is, well, how does all affect the interpretation of the relational operator, greater than, less than, etc., compared to a list? So we have a table here to help you figure that out. So if we say x is greater than all in 1, 2, okay, it means that it's greater than the greatest of them. So that's the same as x is greater than 2. Okay, but again, remember, we're not hard coding this. We're kind of imagining we had a subquery that returned a 1 and a 2. Okay, if we say that x is less than all of 1, 2, well, then it has to be less than the smallest. It has to be less than 1. Okay, if we say that x is equal to all of 1, 2, we mean that x is equal to 1 and x is equal to 2. This will never be true, right? Because this is at the same instant. It's either equal to 1 or it's equal to 2, but not both. Okay, so this isn't a real useful expression. And x is not equal to all of 1, 2. We're saying that it's the same as saying x is not in 1 or 2, so it's not equal to either of them. Okay, so usable expressions except for that third one, that isn't ever going to match. Okay, let's look at the next one. Okay, so here's a query that uses all. So select vendor name, invoice number, invoice total from invoices join vendors on vendor ID. Okay, where invoice total is greater than all. Okay, so, and then we're going to have invoice total. That's a single value. Okay. And now we're going to select invoice total. That's a single value from invoices where vendor ID equals 34. So we're getting a list back. Okay. And we're saying it's greater than all of them. So for instance, if we run the subquery by itself, we'll see it looks like the highest one is 108358. So the results set, you can see that we're only looking at 4 of the 25 rows, but you can see the invoice total is always greater than 1083.58. Okay. What about any? Okay, well, that's going to operate a different way. So let's go through the table of actions for this. So if x is greater than any of a list, 1, 2, well, then it's a greater than 1. So it only has to be greater than the smallest to be true. If x is less than any of 1, 2, well, it only has to be less than the largest, 2. If x is equal to any of 1, 2, it's the same as x in 1, 2. So this is a useful statement. And then if we say that x is not equal to any of 1, 2, we're saying that x is not equal to 1 or x is not equal to 2. So if, for instance, x is equal to 4 or 5, well, then it would pass the test. So where does that take us? Well, to a query that uses any. So we're selecting vendor name, invoice number, invoice total from vendors join invoices again on vendor ID, where invoice total is less than any, and then we're selecting invoice total from invoices where vendor ID equals 115. So it has to be less than all of the invoices for vendor 115. So let's see. Um, we have the subquery. If you ran it by itself, you'd see that the lowest of these invoices is $6. Okay. Oh, I'm sorry. It's not the lowest. I go for this every time I do this lecture. I go for the wrong option. Remember, I'm sorry. If we go back here, if we say it's less than any of 1, 2, it has to be less than the largest 2. Okay. So what's the largest in that subquery? Well, the largest in the subquery is 25.67. Okay, so let's see the results set for invoices with totals less than any vendor for any for vendor 115. Well, 1550, 1663, these are all less than 25.67, but you'll notice all but one are greater than 6. Okay, so sometimes you really have to think about what you're asking for. And I've been caught on this the last 2 times that I recorded the lecture, so uh, I'm not perfect. Okay, so what's a correlated subquery? Let's think about this, okay? In all the subqueries that we've used so far, we've brought back either a single value or a list of values that can be used for all the rows in the they can be used to test all the rows. So we have a where, okay, and we compute either a single value or a list of values, and we compare each of the rows to that. What if we wanted the comparison to be different for each of the rows that we're comparing to based upon some context that has to do with that row? Well, that means instead of doing one subquery, you're doing a subquery per row. And that's called a correlated subquery. And it's just, you're asking a more sophisticated question. That's all that's going on. There's a lot more computing power that goes into answering that query, right? Because it is going to have to run a subquery for each of the qualifying rows. If the subquery, for instance, is in the where clause, it's going to run one for each of the qualifying rows. Now, you might ask me, does it really run one subquery for each of the rows? Well, I think that it's probably true that if the query is going to be the same, the subquery, it turns out, is going to be the same for 2 rows in a row in sequence. It's probably smart enough to not do it again. Okay, so probably it's allowed to save time by going, oh, I don't have to do that again. I already have that answer. All right. Okay, so let's look at this. Select vendor ID, invoice number, invoice total from invoices I, where invoice total is greater than, and then we're going to compute the average of the invoice totals for this vendor. Okay. All right. So we want to get a list in the result set. We want a list of invoices that are greater than average for the vendor. Okay. So could that change on every row? Well, yeah. If every invoice was for a different vendor, that would be true. Okay. Interesting. We say order by vendor ID. So in fact, if you do order this by vendor ID, well then the invoices where the vendor IDs are going to be the same. Maybe you could just do one query for all those and get the average, and then you'd only have to run the query again when you came to the next group. Okay. So let's see. For vendor 95, which is only one of the one of the rows, okay. The average is $28.50 and some fractional change there. And so the result set is a bunch of invoices that are greater than $28.50. Okay, but the thing is to realize, because this where refers to the vendor ID, which could be different on each row. It's probably not different on each row because there are probably groups of them, but it could be different on each row, and at least every time it changes, and possibly for each row, you're going to have to run this query again to find out what the average is for that vendor ID. Okay, so it's correlated in that sense. This is called a correlated subquery. The exists operator, really cool operator. I love this. So we can either use exists or not exists, and then we have a subquery. So the question that we're asking, does this subquery return any rows? Okay. If the subquery returns one row, then exists is true, not exists is false. If it returns 0 rows, then not exists is true and exists is false. So the question that we're answering, does the subquery return 0 rows or more than 0 rows? Okay. So let's look. Select vendor ID, name, and state from vendors where not exists. Select all columns from invoices where vendor ID equals vendor's vendor ID. Okay, and interesting, we get 88 rows, which is, again, these are the vendors who do not have invoices. So how do you figure it out? Well, this is a correlated subquery, right? So we're going to read the vendor, then we're going to select the invoices for that vendor, and if it's empty, well, then it's going to pass because we're looking for not exist. If it has at least one row, then it's going to fail. It's not going to be in the result set. So I think we've already seen 3 different ways to ask this same question. Okay, so it's pretty interesting. Here's a subquery and a select clause. Okay, so we're going to select vendor name, select the max invoice date from invoices for that vendor as latest invoice from vendors, order by latest invoice descending. Okay, so what is interesting here is that we have 122 rows, okay? I'm remembering we have 122 vendors. So we're getting 1 per row, okay? Now, that means that we're going to have some rows, okay, that don't have any invoices. And I'm going to say offhand that latest invoice is going to be a null. Okay, but wouldn't it have been great to have seen one of those rows? Okay, and in fact, let's go look at what answer that gets. Okay, I'm predicting it's going to be a null, but I've predicted some things that were wrong before. I don't know why that happened. I can't just copy that. Let's see if I can copy that. I'm hoping I can. So I've got this, and I'm just going to ask for a new thingy here. And there it is. And I'm just going to throw a use AP before it. Use AP. And we're going to give it a semicolon down here, and let's give it a run. All right. Now let's see what happens when we don't have. There's the nulls. Okay? So we got nulls. Wouldn't it have been nice to have seen those? Okay? And we say order by latest invoice descending. Now what's interesting is that nulls typically sort first. Okay? And because we said descending, they're showing up last. Here are all the nulls. There we go. As I remember, there were 88 nulls and 34 proper ones. Okay? How about that? Okay. We get a null. Sometimes my intuition is just perfect. Emphasis on sometimes. All right. Let's go on. Okay. Now the same query restated using a join. Okay. So it's just we're saying from vendors left join invoices. Okay. So what's going to happen? Well, we're going to get all the vendor names because they come from the left part, from the vendor. And then the latest invoice is going to again, it's going to have an entry on all of the vendors that have invoices, and then it's going to have a null. Well, we're used to that because we know that's how outer joins, and again, I usually use a left join for an outer join. That's how they work. Okay, but it would have been nice to see a few nulls on this graphic as well. All right. Okay, a query that uses an inline view. What's an inline view? Well, it's a pretty cool thing. We're going to have a whole chapter on views. Okay, so then the question is, what's an inline view? Well, it's a view that is inline. It's not a named view. You'll remember that the select returns a result set. And one of the beautiful things about the result set that we get back is it's a table. Hang on one second. Excuse me. So, it turns out that we can create these views, and you can think of them as kind of temporary tables. They're just tables that show what that query would bring back this instant. Okay, and because it's a table, because result sets are tables, no matter how simple they are, we can query it. Okay, so the first way that we learn to do this is that we learn to just use a subquery in the from. Okay, where we would use a table name, and you'll notice it's in parens. Okay, like the other subqueries, there's a select, and we typically give it a table alias. Why do we do that? Well, I think in MySQL you have to. Well, there's no other way to refer to that table. It doesn't have a name. So in this is a case where you actually need a table alias, and people usually use T. If there's only one, they use T. Okay? So we're saying that we want to select the vendor state and the max of invoices uh, as max sum of invoices from, and then we have this. So we select the vendor state, the vendor name, sum all of the invoices from vendors join invoices on vendor ID, group by vendor state, vendor name. Okay, so and then we select the max. Okay, so uh, why do we like these? Well, we like views because they simplify our work. Okay, instead of having to come up with a single select that has all the joins and the wheres and all this kind of stuff that'll get us exactly what we want. It's sometimes easier to think of this as two or more steps. Okay. And in the first step, you create the view. And in the second step, you run a select against that view. Now, does the server keep views? Uh, the general answer to that is no. They're kept for just the life of the query that they're used for, and then they're discarded. Okay, so they really are not uh, permanent tables in any regard like the base tables. Every time you use them, all the computing work is done to create them, and then they live for the length of your query, and then they go away. There are SQL products uh, that have, uh, I'm thinking of Oracle has this thing called materialized views that actually keeps them around for a while and it keeps refreshing them. That's not part of the SQL standard, and that's a fancy feature on the paid version of Oracle. Materialized views. Generally speaking, uh, views are perishable. Even when we get to the chapter where we learn um, how to create the ones that we name, which, as I remember, is chapter 12, uh, even the named ones are perishable. They don't persist, okay? Every time you use one, even if it has a name, when we learn how to name them, then we can use the view name instead of a table name. But every time we use them, it's recreated for us. So it's potentially inefficient, okay? On the other hand, trying to get the same functionality in one select is a lot harder and harder to understand, harder to code, harder to maintain over time. Okay? So this is an inline view. This is our first taste of views. Pretty cool stuff. So it shows us when this gets executed, the first thing that happens is that they run the subquery that creates the inline view, and then they use that within the outer query. A lot of times we'll call this the inner query and the outer query. Okay, so it runs the inner query and it gets the result set, holds onto that table, runs the outer query against the results that came from the inner query, and here's the results that you get. Sorry. Now, here's a complex query that uses three sub queries. Okay, so you don't only have to use one. Okay, it can get pretty exciting. Okay, so here we are. We've got here's one inner query, and then what they've done is they haven't named it. Okay, but they do have a comment that describes it: invoice totals by vendor. And we go through it and we'll see that it gives us invoice totals by vendor. And we gave it the alias T1. Now you'll notice that up here in the select, when we're trying to disambiguate the what we're referring to, that we're using the table alias T1.vendorState T1.sum of invoices. Okay. Now let's go on. Now we're going to join, and again, we have, instead of having a named view, what we've done is we have an inline view, and again, we put a comment up here to describe it. Top invoice totals by state, okay, and that's what you would think it would be from the description, and that's called T2. Okay. And then we say group by vendor state, and then that's a T3. And then we have an on, and then we have an order by. Now, should this sound complex? Yeah, it should sound complex. Okay, but it would be much more complex if you tried to do it without subqueries. Okay, perhaps infeasible to write the query without subqueries. I just want to back up here. I'm going to put this on pause until I'm confident I'm in the right spot in the slides. Be right back. So, I'm back. I was in the right place after all. I think I'm remembering the last version of the slides. Apologize for that. Okay, and so when we run this, what do we get? Well, the result set has vendor state, vendor name, sum of invoices, and it's got 10 rows. It would have been nice. I guess they standardized on showing us 4, but we had room for 10. They should have shown us all 10, I think. Okay, so what if you want to do a query like this? It's got subqueries. How in the world do you do it, right? Well, that's what we're trying to answer now. And we use an approach that we call pseudocode. So those of you who have had a programming course have probably heard about pseudocode. It's a way to kind of write a specification for code that you're going to write. And it's there's no real standard for pseudocode, okay? Pseudocode is English prose, okay, written in a narrative kind of style that would be easy to write a sequential program code from, okay? So the kind of the narrative style of a series of English sentences kind of works like the sequence of statements that are in a procedural program, so that's good. And so it's a mix of English and whatever programming language you're trying to use. So, for instance, sometimes we we joke, those of us in the U.S. who have a hard time learning a foreign language, that when we're trying to speak Spanish, that we put so much English into it that we're speaking Spanglish, okay? Or with French, that we're speaking Franglais. Okay, well, it's the same kind of thing. It's not SQL; it's English and SQL. So it's SQL-ish, SQL in English. All right, and this is just a helper, so we get the idea of how the query is going to work before we try to write it. Okay. So how would we do it? This is a recipe for that. State the problem to be solved by the query in English. Use pseudocode to outline the query. So this would be kind of a pseudocode version of what you just wrote in English. You could start with the pseudocode if you were comfortable with that. Code the subqueries to test them to be sure that they return the correct data. So when using subqueries, you've kind of seen throughout the chapter, in a lot of them, we kind of showed you what the subquery would bring back by itself. This is a great way to build subqueries. Okay. Uh, uh, Build a subquery as itself, run it and test it, make sure it works, okay, and then just cut and paste it into um, the eventual query that uses that as a subquery. We would really like all of our parts to be tested before we assemble them into the whole and test the whole, okay, and then code and test the final query. Okay, so here's the pseudocode for a query, and when you look at it, this is how pseudocode often looks. It looks a lot like the code, but it doesn't. It's pretty free with using English phrases or words instead of what the real code would be. So we say select vendor, state vendor name, sum of invoices. That's probably pretty good SQL from, and then we have in parens, which is a good thing because it's going to be a subquery. Subquery returning vendor, state, vendor name, sum of invoices. And then we say join, and then we say subquery returning vendor, state, largest sum of invoices. On vendor, state, and sum of invoices, again, this is back to SQL. Order by vendor, state, that's back to SQL. So this kind of free intermingling of English phrases, English words, phrases, and sentences with overall SQL, classic pseudocode for SQL. Okay. Where do we go next? The code for the first subquery. So select vendor state, vendor name, sum invoice total, sum of invoices. From vendors, join invoices, group by vendor state, vendor name. So we're getting the vendor state, the vendor name, and the sum of invoices. Okay. Okay, and now what had we called that? We call that subquery returning vendor state, vendor name, sum of invoices. That sounds like what we asked for. Okay, so we get 34 rows, which makes sense because if you think back, we had 34 vendors that had invoices, and we had 88 that didn't, for a total of 122. So we get the state, the vendor name, and the sum of their invoices. That looks good. All right, let's write the second subquery. Okay, select vendor state in the max of the sum of invoices as sum of invoices from, and then we have a subquery. Okay. Now, what's interesting is this second subquery has a subquery of its own, right? Now, when we're testing it, it's out here just inside of a select, but this subquery that we're seeing here after the from, this is going to be 2 levels down when we put it into the end query, right? So select vendor, state vendor name, sum invoices, the sum of invoices from vendors, join invoices, group by vendor, state vendor name. Okay, so what do we get? We get 10 rows. We get the vendor state and the sum of all the invoices in that state. Okay. And this is the result of the second subquery. So what would we do? Well, we would turn around and we would paste these into what is a pretty easy select, but we would paste the two subqueries in exactly where those parenthetical expressions are that include the English. And then we would test that. Now, we don't show that step in the slides. Okay? All right. Okay, so what we've done is we've come to the new content, which I'm going to put into part 2. So we're going to finish this up, and I'll see you again with part 2. Bye-bye.